So how much error are there in these Taylor polynomial approximations? So let's say we have f of x equals sine x. Well, our Taylor polynomial is going to be 1 plus or 0 plus 1 x minus c plus 0 plus 1 over 3 factorial x minus c cubed, etc., all the way to infinity. And if we are going to estimate this with a cubic approximation, we would cut it off right there. And what that means is that that black part represents our approximation. The rest of this is going to be our error. Okay, we're going to call this something. The rest of this are the remainder terms. So we're going to call this, give it a name. We're going to call it the remainder, and we're also going to call it r of x. So for example, in this particular case, since we went to n equals 3, we're going to call that r3. And to calculate the remainder after 3 is all the terms after 3. So that means we're going to sum up all the terms from n plus 1, or we're going to sum it up from 4 to infinity. Okay, so the rest of that series to infinity, starting at 4, represents our remainder, or how far off we are from the actual value. So to do this, we would need to actually have an infinite number of terms. Okay, well, that's not really practical. So it's not really practical to calculate the exact error. However, there are ways that we can estimate the error, or at least bound the error between a maximum value and a minimum value. And we're going to see that there are ways to do this. And it actually is going to involve something that is part of the remainder term. So we'll take a look at that a little bit later, but we can use this remainder term to actually estimate error. We would need an infinite number of them to actually calculate the exact error. Not practical, but we can use this somehow to estimate the error.